This is lesson 89, number 16. We got 3 secant squared theta plus 5 secant theta minus 2 equals 0. I am hoping that I can factor this and use the zero product property on it. So when you factor a quadratic that has a number in front of the squared term, you have to kind of do it the long way. So I have to take the 3 times the negative 2, which gives me negative 6, and that's what I need to multiply to, and I need to add to 5. Okay, so that's different than how we do it when we do it the short way, because we have this number in front of secant squared theta. So what number could that be? 6 times 1 or 3 times
Dawn?
2? Yes?
I just got a phone call. Kendra's sick.
Oh, thank you.
Uh-huh.
Okay, 6 times 1 or 3 times 2. So, these would have to both be negative, so that's probably not going to work. I mean, they'd have to both... Wait, what? Let's do this. How about positive 6 and negative 1? Because then they multiply to make negative 6 and they add to make 5. So I can't just throw them in here. I can't just go secant theta plus 6 and secant theta minus 1. I have to... you can either factor by grouping, or you can use this area model. I've kind of started switching over to the area model. So the area model, you put the squared term in the top left, and then you put the constant in the bottom right, and then you put the 2 numbers that you just discovered, which actually add up to that middle term. Just stick those on the sides. So I can put them in whichever order I want. I could put the 6 up here and the negative 1 down here, or I could do it vice versa. It wouldn't matter. And then I ask myself, what times what? You know how like length times width equals area. What times what equals that? Well, probably going to be a secant and a secant here. One of them's got to have a 3 on it. I don't want the top one to have a 3 on it, because then when I multiply this times the side, I'll have a 3, and I know there's no 3 here. So I want the 3 to be on this side. Now that times that makes that, so we're all good, right? So now I can maybe go down here if I want to. Secant times something equals negative secant. That's going to be negative 1 right there. And then this one times something equals that. Well, that would be times 2. And then check and make sure that checks out. It does. So this is 3 secant x minus 1. And this one is secant x plus 2. And then we're going to use zero product property. So this one's going to give me secant x equals 1/3. This one will give me secant x equals 2. Oh, negative 2. Is that right? Okay, and then so secant is the reciprocal of cosine. So this is kind of the same as saying cosine x equals 3. Can cosine x ever equal 3? You're supposed to say no. It's supposed to be between negative 1 and positive 1. So this one would give me cosine x equals negative 1/2, and I know I can, so I gotta get x by itself so I can inverse cosine both sides. So basically I can just whip out my unit circle, find out the angles where cosine x equals negative 1/2. Cosine is the first of the ordered pairs, so cosine looks like it's going to be a negative 1/2 at 120. Are we in degrees here, I wonder? Let's see if we're in degrees. Yes, we're supposed to be in degrees. So, 120. And then there's somewhere else, probably, like right down there. I got 240. And I think that's it. We're done.